Good evening. I'm back to Dr. Tamiru and Dr. Varatin. I'm Muhammad Shakir bin Abdul Salam, and I will be the representative for Group 29. And today, our group will present a project about the Smart Laptop Cooling Pad. So without further ado, let's start our presentation. In our project, we are going to focus on these few elements. Those elements are, the first one will be the introduction section. So in introduction section, we will discuss on the project background, problem statement, objective and scope. Moving on to our second section, which is a literature review. So in this section, we are going to discuss on the current laptop cooling fan that exists in the market. And then moving on to the third section, which is the methodology section. In this section, we are going to discuss on the several design that has been made by our team members. For those design, we are going to evaluate it using the evaluation process tool, which is using evaluation weighted decision matrix. And next, we are going to choose the components for our project. So in our project, we are going to use Arduino Uno and the TMP35 temperature sensor. Moving on to our next section, which is the results and the project demonstration. So in this section, we are going to discuss and show the simulation of our Arduino. And moving on to the next section, which is the business consideration. So in this section, we are going to discuss on the cost of our components and the cost of overall model. Next, the last but not least, we are going to conclusion and recommendation section. So in this section, we are going to conclude our project and state any improvement that we can make for our future project.
So, let us move on to the introduction, which is on the project's background. First of all, there are three main sources of heat that is released by the laptop, which is from the CPU, the GPU, and also the HDD. Poor air ventilation and airflow circulation can cause the laptop to be overheated. This overheating can cause the laptops to lag or freeze when the laptop is in operation of executing heavy computational tasks. A normal laptop fan will run continuously with or without the laptop being in an overheating state. This continuous running of fan can contribute to the waste of energy from the laptop's battery, and it is also not environmentally friendly. Now, let's take a look at the problem statement. Overheating is a common problem that is faced by all laptops. In this era, people rely on laptops in their everyday life, whether it is for education, businesses, or work purposes. For example, poor air ventilation and circulation can be caused by the accumulation of dust, which can cause the laptops to be overheated. This problem can reduce the efficiency of the laptops, which can degrade the laptop's performance and stability, which could lead to a system crash and a hardware failure of the laptop. A normal laptop fan will run continuously whether the laptop is in a overheating or normal state. This could lead to the waste of energy from the laptop's battery, and it is also not environmentally friendly. Thus, this automated laptop cooling fan is designed to capture real-time temperature and eliminate the need for an external power supply. This project can be divided into two parts. The first one being to design an automated laptop cooling fan that can utilize the heat energy that is wasted by the laptop. Secondly, to make use of the sensors, actuators, and mechanical system in building an automated laptop cooling fan. As you can see in the objective section, there is an image labeled number 2 which shows the sensors and actuators which are going to be used in this project. The scope in this project can be divided into three, which are to make a working design as the benchmark for a real product of an automated laptop cooling fan. to build an electric circuit with the components such as sensors, actuators, microcontrollers and microprocessors, such as temperature sensors TMP36, cooling fan, light emitting diode, which is also called LED, Arduino Uno, and resistors using an online simulator. It can be noted that in our project, we are going to use Arduino IDE software to conduct our Arduino Uno coding.
Moving forward, today I'm excited to present a literature review for our project. Firstly, we will explore the ICE Coral K8 laptop cooling fan and its sensor. Then, we'll discuss the versatile Arduino Uno microcontroller board and its role in the laptop cooling fan project. Laptop overheating is a common problem that can affect its performance and lifespan. That's where the ICE Coral K8 laptop cooling fan comes in. This portable and lightweight fan channels the hot air out of the laptop, preventing it from overheating. It also comes with adjustable speed and stand to suit our needs. In addition to its fan, as stated by Meiji and Rajagonda, the ICE Coral K laptop cooling fan is equipped with temperature sensors to monitor laptop's real-time temperature. The most commonly used sensor in the laptop cooling fans are resistors, thermocouples, and thermistor due to their stability and high accuracy. So moving forward, second part of the literature review, which is Arduino Uno in laptop cooling fan applications. So first of all, what is Arduino Uno? Arduino Uno is a microcontroller board based on the ATmega 328P microcontroller. It can be powered via USB or an external power supply. It supports various programming languages such as C, C++, and Python, and it's all available in Mac, Windows, and Linux. Arduino Uno is widely used in projects such as robotics, home automation, and Internet of Things. One interesting project involving Arduino Uno and a laptop cooling fan was developed by Khalid in 2018. Khalid used an Arduino Uno to control the fan speed and monitor the laptop's temperature using LM35 temperature sensor. The component used in the project also included a DC-DC step-up module XL6009, Darlington transistor TIP122, DC cooling fan, LED, and LM35 temperature sensor. The LED will monitor and shows to us the temperature, while the sensor will detect the temperature of the laptop, and then it will send the signals to Arduino, and then through a fan connected, it will control or physically control the heat or the temperature of the laptop through the air that is being conducted from the fan into the laptop. Alright, so from the research and the investigation that we did, we have come out with 4 design options, which is concept A, B, C, and D. So each of the concepts have its own ideas behind it. So for concept A, the main idea is to remove the hot way inside ways, whereas for concept B, it removes air directly from the bottom of the laptop. And for concept C, it removes air vertically from bottom of the laptop. And for concept D, it mainly focuses on having a cardboard as the proposed material, making it very environmentally safe and having an excellent airflow. These are the 4 options that we have come up for our projects. Alright, so moving forward, from the 4 design options, we have evaluated the design based on 4 criteria, which is the effectiveness of the design in removing the hot air from the laptop, portability of the design, complexity of the design, and the eco-friendliness of the design. Out of 4 criteria, concept B outshines the rest of the design with 3.35 of summations of scores, which makes the concept B as the selected design for our project.
So, moving on to the selection of the component. For this project, we'll be using Arduino board that will act as the brain for the system. So, Arduino Uno board was chosen because it has a user-friendly interface, a simplified programming language, and free built-in libraries that make it easy to get started. And it is a low-cost main component also. So Arduino Uno has a power regulator on the board to control the power coming to the controller. This helps to maintain constant power in the board and protect the board from a short circuit. In conclusion, the most suitable Arduino board is Arduino Uno since it has a simple programming and has a maximum voltage input up to 20 volt. The next main component for this project will be using a temperature sensor, which is a temperature sensor TMP36. So it is an electronic device that measures the temperature of its environment and convert the input data into an electronic data. So the temperature range for the TMP36 are good, which could support the normal overheating temperature of laptop. Moreover, temperature sensor TMP36 also suitable to be used together with Arduino Uno board as it supports operating voltage within the range 2.7 volt to 5.5 volt. This makes it a suitable choice for measuring the temperature of the laptop and controlling the fan speed accordingly. So in conclusion, using Arduino board and temperature sensor TMP36 allows for a simple and effective way to create a smart laptop cooling pad that can adjust the fan speed based on the temperature reading. This can help to prolong the lifespan of the laptop and prevent it from overheating, which can cause damage to the internal component.
Next part will be on the project demonstration part. First of all, we will take a look at how would the circuit connection of this smart laptop cooling pad would be. In the table on the left is the listed down components and its quantity used, while the diagram on the right is the circuit connection crafted using online simulator Tinkercad. Arduino Uno R3 is the motherboard shape looking on the bottom of the diagram, which is actually the brain of the system, where we will write codes to give it commands, and when certain temperature triggers it, certain execution order will take place. Brushless DC fan is the one on the top left that stimulate and be our fan for the laptop cooling pad. Meter resistor with 5k ohm resistance is located on the board, and there are two of them, in which could be spotted only below two colored LEDs, which would be in red and green color. There are 14 jumpers wires connection throughout this whole board. The breadboard is the whiteboard with rows and columns of connection port where all circuit connections take place. Cable for Uno is the USB looking thing on the bottom left. And lastly would be our selected temperature sensor TMP36 located in the center of the board, which temperatures can be manipulated to stimulate temperature of laptop in real situation. Next part is the Arduino IDE coding, which are the inputs for Arduino Uno R3. We are using C++ computer language for this. This coding is what makes the cooling pad able to be turned off and on at certain temperature range. Firstly, we would declare all of the variables and functions library in order for the codes to be able to distinguish parts and execute orders. Next, we will give the code for the temperature calculation, and then finally for the execution commands, there are three different conditions and executions. First condition, when the temperature is below or equal to 45 degrees Celsius, the green LED is lit while the red is turned off. This to indicate that the laptop working temperature is still in the acceptable range. Next condition, when temperature is in between of 46 to 60 degrees Celsius, the green LED is turned off while the red LED is turned on. This to indicate that laptop temperature is gradually increasing and soon will reach to the hot zone. And last condition is when the temperature is above 60 degree, the red LED remains on but the DC motor will run. This is to show that the laptop temperature is now in the hot zone and the DC motor, which would be the fan, will blow to cool down and reduce the temperature back to the acceptable range. Alright, this would be our project demonstration through Tinkercad simulation. First of all, after we craft the right circuit connection, we will load the code to the Tinkercad program, which can be seen on the right half side of the video. And then when we hit the start simulation button, we can see that the green LED is on. This is because the temperature for the temperature sensor is now at 25 degrees Celsius. When we manipulate the temperature to 47 degrees Celsius, which are in between 45 to 60 degrees, we can observe that the red LED is lit up instead of the green one. However, the DC motor will not run yet. When we further increase the temperature to 61 degrees Celsius, the red LED kept light up, but in addition, the DC motor now is running. This would cool down the laptop and brings down the temperature to normal acceptable range. And when we revert back the temperature back to 29 degrees Celsius, which are below 45 degrees, the DC motor and that LED will be turned off and the green LED is light up. And that is how basically how the smart laptop cooling pad project of ours work.
Forward to business and economic consideration. As we can see, from business consideration, this project will be beneficial to the users because it does not need an external power source. Besides that, it is also marketable because there are not many options of automatic laptop cooling fan in market. For economic consideration, laptop cooling fan can be embedded into existing laptop stand, so we can save more money. Besides that, the components to build this project are easily can be found in the market. So, we already arrived to our last section of our presentation, which is the conclusion section. So, we will go through some suggestions for improvements that could make the user experience better when using the automatic cooling fan. First, it is best if speed of the fan can be changed accordingly to the constantly changing temperature. This will make a cooling process more efficient. Second, display for fan speed and laptop temperature can be added. This can help users be aware of their laptop heating problems. If their laptop are always overheating, even when the fan speed are at maximum, this could be because of other issues such as a build-up of dust or laptop are handling heavy workloads for a long time, such as running heavy software such as design software like AutoCAD. Last but not least, it is to incorporate passive cooling together with active cooling. This can be done by choosing more thermally conductive material and using fin design for better heat transfer to environment. That's all from me. Thank you.